Okay, today we're going to do a couple of pre-quests for 6-4 to 6-6. So these are the pre-quests, 6-4 to 6-6, and we'll start with number 1. And problem 1, this is pre-quest number 1, problem 1, says we have the ordered pair 3, 162, and we are going to change that into rectangular coordinates. So that means we have polar, we have r and theta, and we want x and y. And we need to make a note, if we have not already, that x equals r cosine theta and y equals r sine theta. So kids, this is incredibly simple. X equals 3 cosine 162 and y equals 3 sine 162. So we just type that in on our calculator, and whatever we get, that is going to be our x and y. So 3 cosine 162, negative 2.85, and 3 sine 162, .93. And that's it. Now, I'm going to do this a little bit out of order because I want you to make sure you see the connection. So I'm going to skip down to number 4. We're going to skip all the way down to number 4 because it is exactly the same problem. The only difference is our answer will not be written as an ordered pair. We're going to find the same x and y. But because we are starting with a polar form number, a trigonometric form number here, we are going to be changing this. We're still going to find x and y, but now it's got to have an I in it. That's an I right there. So it's going to be x plus yi. So it is exactly the same x and y. We're going to find it exactly the same way, but we're going to write our answer with an I since the problem had an I. Notice this problem, number 1, was an ordered pair, so my answer is an ordered pair. This problem is a number with an I in it. Remember, this is cosine I sine. That's an I. So my answer has to have an I on it. But x and y are going to be found the same way. This is your r and this is your theta. So x is going to be 5 cosine 100, and y is going to be 5 sine 100. I'm going to type it in exactly like I typed it in before, 5 cosine 100. But this time, I'm going to write negative 0.87 plus 5 sine 100, 4.92i. So I'm doing everything exactly the same for problem 1 and problem 4. I'm doing it exactly the same. The only difference is problem 1 is an ordered pair. So I have x comma y. Problem 4 is a number with an I in it, so I have x plus yi. Okay, so that's 1 and 4. Now we have to do 2 and 3. And they are exactly the same. They're going to be done exactly the same. And it'll just be a matter of how we write our answer. So notice that for number 2, this is number 2, it says 3 comma negative 4. And we're going to change that into polar coordinates. So we have an x and a y given to us. And we need to figure out the r and the theta. So remember, when we do this, we draw a little picture. Over 3, down 4. This is r. And this is theta. So to find r, I'll square the first one, square the second one, add them together and take the square root. This time it works out to be just 5. So my r is 5. Then I'm going to find this angle right here, the one inside the triangle, by using the tangent. I'm going to say the tangent is 4/3. So I'm going to second tangent 4/3. And that's going to give me that angle right there. So second tangent 4/3 is 53.13. So this guy is 53.13. But theta is the whole angle, this whole thing, which is almost 360, but not quite. So I'll subtract 360 minus 53, and I get 306.87. So my theta for this angle, or for this number, is 306.87. Notice the problem was an ordered pair, so my answer is an ordered pair. Now, when you look at the next problem, number 3, it is exactly the same thing, only this time you have an I in your answer. This is your X and this is your Y. So we're going to do the same thing. We're going to go over 2 and up 3. We're going to find our R, and this time our theta is right here in the angle. So this, or in the triangle. This is an easy one. We're going to do it exactly the way we did it before. Exactly the same. Except because this has an I in it, we're not going to write an ordered pair. We're going to write our answer like this. So our R, CIS, theta. So what's R? Square the first one, square the second one, add them together and take the square root. That's root 13. Pythagorean Theorem. R is root 13. Now, tan theta equals 3/2. So theta equals second tangent 3/2. I am doing exactly what I did in my last problem. This one's a little easier though, because when you do second tangent 3/2, you get 56.31, and that is theta. So root 13 CIS, 56.31. Remember, if you're in quadrant 1, you don't have to make any adjustments. Whatever the calculator says is the answer. When you're in a different quadrant, that's when you have to make adjustments. Subtract from 360, add 180, whatever you have to do to adjust. But here is the answer to problem number 3. And what I absolutely hope you see is these two problems, the math is exactly the same. Exactly the same. The only difference is when it starts out as an ordered pair, you answer as an ordered pair, 5,306. When you start out with a number with an I, you have to answer as a number with an I using your CIS notation. And that's the first page already done. All right, so let's go to the second page now. Number 5. Okay, so number 5 says, convert to a polar equation. Well, I had it written down here earlier and I erased it. What does x equal? What does x always equal? X always equals r cosine theta. And y always equals r sine theta. Done. X equals r cosine theta. That should be written on every page, highlighted. We use that over and over again in all kinds of problems. 6 is a little bit harder. Not hard, but certainly harder than that. We're going to convert this to a rectangular equation. So the first thing we do is replace the function, so sine or cosine or tangent or secant, whatever you have, replace it with its definition. Now, I don't mean with its opposite over hypotenuse definition with its actual letter definition and what we call the unit circle definition. So r equal, or not the circular definition, r equals 4 sine theta. Sine, by definition, is y over r. Those were memorized way back in the days of our gold sheet, way back in the first semester. If you've lost your gold sheet, so I'll try to find it. But if you can't, you need to look up these definitions in your book and make sure that you know the definitions of all the functions, the circular definitions, so that you can plug them into these equations. Now, no matter what the function is, the definition is going to be a fraction, so you're going to have a fraction here. So the next thing you're going to want to do is clear the fraction. So we have r squared equals 4y. And then we remember our Pythagorean theorem that says x squared plus y squared equals r squared. If this is x and this is y, that's r. X squared plus y squared equals r squared. So we're going to take out this r squared, and we're going to replace it with x squared plus y squared equals 4y. So we're just substituting in x squared plus y squared, and that is the answer to the question. So you replace your function with its definition, get rid of the fraction, and then do whatever you need to do. In this case, replace r squared with x squared plus y squared. Okay. Now we have two numbers given to us. These are just random numbers, nothing special about them. And we are going to multiply them. So do you remember how to do this from your notes? Get your notes out, take a look at it. When you multiply numbers in polar form, it's called polar form, trigonometric form. When you multiply numbers in this form, you multiply their r's, so that would be 48. This is r, this is theta. So you multiply their r's, so that's 48. And you add their angles, so that would be 250. 100 plus 150. You multiply the r's, add the angles. Done. Now we're going to divide them. Now when we divide, we do sort of the same thing, except we divide the r's. So that would be 6 over 8, which I'm going to reduce in a minute, but I'll just go one step at a time. So 6 over 8, divide the r's, and subtract the angles. So 6 divided by 8, and 100 minus 150. Now, this answer needs some work. First of all, 3/8 is 3/4. Feel free to make that a decimal if you prefer. It doesn't make one bit of difference. Second of all, you cannot have an angle less than 3 or less than 0. You cannot have an angle less than 0. So we need to modify that angle. And remember, when we're modifying our angle, we either add a revolution, that is 360, or we subtract a revolution. Well, obviously subtracting isn't going to help me here. It's still going to be negative. So I'm going to add 360, and that is the answer to the question. If this angle turns out less than 0, you need to add 360 to make it positive. If it turns out bigger than 360, think back to your notes. If it turns out bigger than 360, we need to subtract 360 to make it smaller. That wasn't our problem here. Okay. Believe it or not, we don't have much to go on this practice test. Okay, so we're going to answer in polar form. So we have negative root 3 plus I, and we're going to take it to the 5th power. Okay, now this is by far the most complicated problem in terms of steps to do. First thing we want to do, this is x and y. We want to change it into polar form. So I am going to find my r and my theta. So I'm going to come over root 3. This is going to be root 3, and this is going to be 1. That's a 1i there. Don't let that confuse you. There's a 1 there. So root 3, 1. So I'm coming left root 3 and up 1. And this is my r, and this is my theta. Okay, so we've done this already. We know how to do this. This is step 1. Believe it or not, there's more. This is step 1. So we'll square the first one, square the second one, add them up, and take the square root. So r turns out to be 2. Okay, now I need theta. So I got to find this angle first. So the tangent of that angle is 1 over root 3, opposite over adjacent. So I'm going to do second tangent 1 over root 3. So second tangent 1 divided by root 3. And I get 30. So this angle right here is 30. Which means theta is what? Theta is 150. It is 180 minus 30. We only got this far. We didn't get all the way to 180. We only got this far. So it's 150. Now, this is not the answer. All you have done is change this number into polar form. You still need to take it to the 5th power. So this is where we use de Moivre's theorem. De Moivre's theorem says take the radius to the power, so 2 to the 5th, and then take the angle times the power. So we're going to take 2 to the 5th and 150 times 5. Well, 2 to the 5th is 32. And 150 times 5 is 750. I'm going to check that on my calculator. Make sure I did that right. And you're basically done. We have one issue, though. Can you see what the issue is? The issue is 750 is way too big. You cannot have an angle less than 0, and you cannot have an angle bigger than 360. So when it happens, and it happens in a lot of problems, when it happens, you have to deal with it. So I want you to take that 750, and I want you to subtract 360. Now, you should get 390. That's still bigger than 360, so subtract another 360, and now you get 30. And that is the answer to the question. So when we get an angle that's too big, we subtract 360 as many times as we need to get smaller than 360. Okay. Now we're going to plot a couple of things. So you've got much better, nicer graph paper than I do, but this is what I've got, so this is what I'm going to use. So problem 9 says we're going to plot point A, which is 3, 2 pi over 3. Now, first of all, your graph paper is labeled in degrees all the way around. So we don't want a radian measure here. So I'm going to change that to 3, the degree measure. So remember, pi is 180 divided by 3 is 60 times 2 is 120. So I am going to plot the point 3, 120. So go to the 120 line and count out 3 circles. 1, 2, 3. So it's right there. That is point A. Give it a nice little A. Label it. Now, B is the point -4, 60. Kids, we've talked about this. You cannot plot a negative R value. Can't do it. So we're going to change that to a +4, and then we're going to change our angle by 180 degrees. When you change the sign on R, when you make that positive, your angle changes by 180. So I'm going to add 180, and I'm going to plot that point then on the 4th circle out on the 240 line. So it's going to be right here, and there is point B. Okay. Now I'm going to sketch my rose. This is going to be a rose. You didn't need to know that before you started, but you'll see it in a minute. So we're going to sketch 5 sine 2 theta. Now, I would like you to have your window set and not mess with it, please. Let's have, first of all, we're in polar mode, so make sure you're in polar mode. Go to mode. Make sure you're in polar. Make sure you're in degrees, which hopefully you have been, or a lot of these problems would be wrong. And now we're going to go to window, and we're going to have our window set with theta min at 0, and theta max at 360, and theta step at 5. Please don't change that. If I want you to change it, I will give you specific instructions. But from now on, this is how I want it set. And I won't be going back through this. So make sure you get it set and go from there. Your X min, X max, and X scale should be -5, +5, and 1. And the same for the Y's. So in window, these are the settings that I want you to have. And I'm not going to write down the Y's. The Y's are exactly like the X's. So let's take a minute and get that set up. So our theta in window, go to window, theta min, theta max, theta step, and then X min, X max, X scale, and Y min, Y max, Y scale, all the same thing. Now, as soon as you have all that set up, go to Y equals right here. Clear out any equation, hit clear, any equation that might already be in there, and put in 5 sine 2 theta. And remember, theta is your variable button right under your mode button, right next to your alpha button, and hit graph. So now you're going to graph this as accurately as you can. So it looks like we have a leaf in every quadrant like this. Now, You may be wondering, Mrs. Ford, how did you know that it went out to exactly here? You know, why didn't it go out to here? Or why didn't you stop here? Because I remember that this number right here gives me the length of the leaves. And so when I draw my rows, my leaves have to be the right length. And the length is 5 in this case. Doesn't it make sense that there's 4 of them? Sure it does, because this number gives you the number of leaves. If it's even, you double it. And there is your nice little 4-leaved rose.